1, 2, 3. 1. Currently getting lake effect rain. There's actually a pretty heavy cell just to my north, like maybe a few miles away. There's some very intense convection just over the lake. And there's more convection to my west as well. So, yep, this is lake effect. This is 100% lake effect rain. This is not caused by any low pressure system. This is not like caused by just, regular run-of-the-mill convection. This is, in fact, lake effect rain here. And yes, the air loft is indeed cold. Usually when the 32-degree line is at this temperature, it's usually snowing. So yeah, the 850 millibar temps are when they're usually like this, it's usually snowing. But keep in mind that this lake effect rain is heading down even down to Binghamton. It's even going down towards like parts of the far north suburbs of New York City. This lake effect rain is extending that far south, far northern suburbs of New York City. Parts of the Albany area are getting rain from this. But the New York City suburbs are just getting drizzle. But yes, I did check the radar, and there's been some pretty intense convection coming off the lake. Even a supercell formed in over northeastern Lake Ontario. There was a supercell that actually impacted parts of northern Oswego and southern Jefferson County. So yes, pretty intense. The reason for this is the lapse rates are steep. It's very moist here at the lower levels right now, especially just a little bit above. You can actually see there's a lot of you can see a lot of reflection in the clouds. There's a little bit of steam coming out, but not much. Temperatures here at the surface are in the mid-50s right now. Keep in mind, the lake temperatures are in the mid to upper 60s. So yes, the difference between the surface at 850 millibars, I would say, is about 20 degrees Celsius. So when I say 20, that's 20 multiplied by 1.8. That's the difference in temperature. So that's about 30 degrees. So it's definitely below freezing at the 850 millibar level. So it's in the lakes in the 60s. The lake temperatures in the 60s, and the 850 millibar level is well below freezing. That's a pretty sharp drop in temperature. It's a very unstable air. So that's why we're getting lake effect rain. Let's say we were having a very Arctic air mass and the lake temperatures were in the 50s or even low 60s. Right where I am, it'll probably be raining mixed with snow, maybe like a slush. But if you go a few miles away from the lake, maybe 5 or 10 miles, or even just 2 miles, it would be all snow, and it would be a heavy, heavy snow. That's why Watertown gets feet and feet of snow, while Oswego usually gets a heavy, wet snow. Because when you're right by the lake's warm, so you're probably going to be in the upper 20s, low 30s when you're getting your heaviest snow. And just go a few miles inland, maybe still in Oswego, and bam, you're going to be in the low 20s, mid 20s, dealing with a much higher snowfall water ratio. So, 1 inch of snow might 1 inch of water might equal 10 inches of snow, or even more, like 20. While here you're dealing with a much smaller snowfall water ratio. Like 1 inch of water might be 5 or 10 inches of snow. So you'd be dealing with a heavier, wetter snow, and be more prone to like collapsing trees. It'll be heavy, wet snow. See, right now we're just getting a steady shower now. The convective part is kind of past, but it's still to my north. I'm going to check the radar one more time right now. can. Damn it, it's definitely pretty dirty. A little better now. All right, there we go. So we're in a little bit of a lull right now. I just checked the radar. So now the southern part of the convective cell is actually becoming more widespread, and now the big drops start to come down. Again, I'm going to check the radar. And it's definitely a lot more intense now. I just checked the radar. There's orange and red in there, so I would not be surprised. We actually see some lightning right now. Yes, there's a pretty intense cell coming in right now. I just checked the radar. The cell is literally right on our doorstep. Like the southern edge of it is, I would say, right on top of us. The reason for this is simple. You get a temperature differential between the lake and 850 millibars. At 850, about 5,000 feet up, it's actually snowing, maybe even hailing at Grapple, because some of this convection is pretty intense. While we're just getting rain here, just a couple thousand feet up, or just maybe a little bit to the north, there might even be some hail in there. Yep, here comes the big drops again. I don't know if you can see them, but yep. See them falling on my jacket. I'm gonna check the radar again, but now we're getting heavy rain. I'm going to make a report on Emping right now. Just give me a moment. Now it is absolutely pouring outside right now. I mean, look at this. Just in the last minute, it just started absolutely pouring. Yeah, it's basically a deluge right now. Just in the last minute or so, just completely started pouring. Keep in mind, we're on the edge of the heaviest convection. The heaviest convection still being like a few miles to my north, which means whoever's in that heaviest convection, I might be getting some hail in there. And true of any lake effect band, look, there's almost no wind in the middle of the band. It's when we're on the edge of it, though, some gusty winds. I mean, there's a little bit of wind, but it's really light. Usually in the middle of a lake effect band is where you have the least wind. And yeah, and almost true to that, the winds have calmed down. They're light and variable right now. These are big drops of rain coming down. I mean, these are big, fat drops of rain. These are the type of drops of rain you get during thunderstorms and during summer. It's a testament to how convective this system, this little lake effect system is. Very heavy lake effect rain here in Oswego. Normally at this temperature, there's not usually lake effect rain, but the air aloft is very cold. That's why we're getting this. It's not what it's at the surface, but what you're getting a few thousand feet up, from the surface up to 1,000 feet. If you look on the radar, you're not going to see stratiform precipitation. You're not going to see synoptic. This is not a synoptic weather event. This is lake effect. This is what is known as basically a local weather event. This is because of the topography. This is a topographical weather event. Lake effect. It's affected because of the lake. And this lake is because of glacial ice. Look. These are big drops of rain. These are some giant drops of rain coming down. No hail, no ice, but big drops of rain. Look at these drops. These are huge drops. There's some small drops, but there's some big drops in there too. And there's more lake effect rain to my west, so tomorrow it's kind of a bummer that it's happening at night because I was hoping to see some water spouts. I mean, I might have seen some if this was during the day, but this is usually the setup that produces water spouts here over Lake Ontario. I mean, if this was a daytime setup, we probably would have seen a few small spouts. Anyway, thank you all for watching. But before I go, I'm just going to check the radar again. Yep, lake effect rain here in Oswego right now. Yep, pretty potent lake effect rain band here in Oswego. Right now the winds are light and variable. You could actually see there's barely any wind. Winds have calmed down. They're blowing a little bit, but 5-10 miles an hour barely. But then as soon as we get away, as soon as the rain stops, the wind just picks right back up. Yeah, the lake effect rain is actually, because you're getting updrafts, you're getting a rising motion, so that's kind of disrupting the wind flow. That's why in the middle of a lake effect band, you might just see snow coming down vertically, as if it was synoptic. Normally, lake effect snow comes down vertically, not horizontally with the wind. In fact, synoptic storms often have wind and snow, blizzard conditions. Lake effect snow might produce blizzard conditions, but usually on the outer periphery of the band. On the north and southern edge of the band, you might get really strong winds, or on the leading edge, on the eastern side, when the band is bearing down on you, you might get some really strong winds, and then it'll just be really just heavy snow coming down with little or no wind. Usually, sometimes you could get blizzard conditions even in the middle of a band, like what happened in Buffalo last winter, but that's more unusual. Usually a lot of the really, really heavy bands that come down, you might get 4 or 5 feet of snow, but you won't get a lot of blowing and drifting. Anyway, thank you for watching. Bye. I'm ending the stream now. The convective part just went off to my northeast. It might produce some lightning and thunder, but I haven't really seen any. And now there's a lot of low clouds coming in now. Now the cloud thick base has lowered. There's now a lot of low cumulus clouds now. You can actually see them a little bit. Those clouds are now down to maybe 2,000-3,000 feet. Yeah. Anyway, thank you all for watching and have a great night.